Tests that only run on your machine are not really tests. They are local scripts that give you personal confidence but tell the team nothing. The whole point of automated testing is that the suite runs every time code changes. On neutral ground, without anyone having to remember to trigger it. That is what CI/CD means in practice. Continuous integration. Every push, every pull request, triggers the test suite automatically. If it passes, the team knows the change did not break anything. If it fails, the developer finds out immediately, while the change is still fresh. GitHub Actions is the most widely adopted CI platform right now. It is built into GitHub, free for public repositories, and requires zero infrastructure to get started. You define your pipeline in a YAML file. Push it to your repo. GitHub handles the rest. Spins up a virtual machine, installs your dependencies, runs your tests, publishes results. In this episode, we are going beyond Hello World. We are building a complete QA pipeline that runs your pytest suite, generates an HTML test report, uploads it as a downloadable artifact, and sends a Slack notification when the build breaks. Everything a real team needs, written in a single YAML file. By the end of this episode, you will understand every line of a production GitHub Actions workflow and know how to extend it for your specific project. Let us cover the anatomy of a GitHub Actions workflow. A workflow file lives in the .github/workflows directory of your repository. It is a YAML file. The name can be anything. Most people call it ci.yml or test.yml. The file has 3 top-level sections. Name is just a label. It appears in the GitHub Actions tab in your repo. On defines what triggers the workflow. Jobs defines what actually runs. The on section is where you control when the pipeline fires. The most common trigger is push, combined with pull request. You can scope it to specific branches. On push to main and on pull request targeting main are the two you want for most projects. This means every commit to main runs the suite, and every pull request runs it before merging. You can also add workflow dispatch, which lets you trigger the workflow manually from the GitHub UI. Very useful for debugging or running the suite on demand. The jobs section defines one or more jobs. Each job runs on a virtual machine. You specify the machine type with runs on. Ubuntu latest is the most common choice. It is free, fast, and supports everything you need for Python testing. Each job has a steps list. Each step is either a use's reference to a pre-built action or a run block with shell commands. Steps run sequentially within a job. Jobs can run in parallel if they have no dependencies. That is the complete mental model. Triggers, jobs, steps. Here is what a complete QA workflow looks like for a Python project. The workflow triggers on push and pull request to the main branch. The job is called test and runs on Ubuntu latest. The steps are as follows. Step 1, checkout. Uses actions/checkout at v4. This clones your repository into the runner's workspace. Step 2, setup Python. Uses actions/setup Python at v5. You specify the Python version. Use the same version your project targets. Step 3, install dependencies. A run block with pip install. You install pytest HTML for reports, and anything else your project needs. Best practice is to have a requirements-test.txt file that pins all your test dependencies. Pip install or requirements-test.txt keeps it reproducible. Step 4, run tests. Pytest with several flags. -v for verbose output. -tb equals short for shorter tracebacks. -html equals report.html and -self-contained HTML. To generate a standalone HTML report file. -unitsml equals results.xml to generate a JUnit XML file that GitHub can parse and display natively. Step 5, upload report. Uses actions/upload artifact at v4. This makes the HTML report downloadable from the GitHub Actions run page. You set the name, the path to the file, and retention days. Step 6, publish test results. Uses a community action that reads the JUnit XML and displays pass, fail, skip counts directly in the pull request. Let us look at that workflow file on screen as a complete unit. Name, QA test suite. On, push to main, pull request to main, workflow dispatch. Jobs, test, runs on Ubuntu latest. Steps. Checkout action. Set up Python with version 3.11. Install dependencies, pip install-r requirements test.txt. Run pytest with all the flags we described. Upload artifact, name test report, path report.html, retention 14 days. Publish results using the JUnit reporter action. And if you want Slack notifications, you add one more step at the end. Uses action-Slack notify. You pass in your Slack webhook URL as a secret, the channel name, and a message that includes the job status. The if condition on this step is always. That means it runs even if previous steps failed. Without always, a failed test run would skip the notification step, which is the exact situation where you most need the notification. You store your Slack webhook in GitHub Secrets. Go to your repository settings, secrets, and variables, actions, new repository secret. Name it Slack webhook URL. Paste the webhook. Save. In the workflow, you reference it as secrets.slack webhook URL. It is never stored in plain text, never visible in logs. This is the same pattern for any sensitive value your pipeline needs. API keys, database URLs, service account credentials. Always use secrets, never hardcode. There are a few advanced patterns worth knowing. The first is caching dependencies. Every workflow run installs your packages from scratch. For a project with many dependencies, that can add minutes. GitHub Actions has a cache action that stores your pip cache between runs. You add a step before the install step that uses actions/cache. The key is a hash of your requirements file. If the file has not changed, the cache is restored in pip install runs in seconds. If the requirements changed, the cache is invalidated and a fresh install runs. This alone can cut your pipeline time in half for stable projects. The second pattern is matrix testing. You can run your suite against multiple Python versions simultaneously. Define a matrix with Python versions 3.10, 3.11, 3.12. Use the matrix value in your setup Python step. GitHub spins up 3 parallel jobs, 1 per version. If something breaks on 3.12 but not 3.10, you find out immediately. The third pattern is test splitting for large suites. Combine matrix with pytest split to distribute tests across multiple runners. Runner 1 runs the first third. Runner 2 the middle. Runner 3 the last. All in parallel. Your wall time drops dramatically. The fourth pattern is environment secrets per branch. Use GitHub environments to have different secrets for staging versus production. Your CI pipeline runs against staging. Your release pipeline runs against production. Separate secrets, separate approval gates. Here is the takeaway from this episode. A CI pipeline for QA is not complicated. It is a YAML file with 6 to 10 steps. Checkout, install, run, report, notify. The sophistication comes from what you do with the output. HTML reports that anyone can download. Test results that appear in pull requests. Slack alerts that reach the team within seconds of a failure. These things change how a team relates to the test suite. When failures are invisible, people stop caring. When failures are loud and immediate, people fix them. That is the actual value of CI for QA. Not automation for its own sake, but automation that is connected to the team's workflow. A failure at 3 a.m. sends a Slack message. The on-call engineer sees it. A failing pull request blocks the merge. The developer fixes it before it reaches main. Your suite runs on every change, with no human intervention. That is continuous integration working as designed. In the next and final episode of this series, we are putting everything together. We are building a complete, portfolio-ready automation framework from scratch. Real project structure. Proper contest. Fixtures. Mocks. Parallel execution. CI pipeline. README. Everything a hiring manager wants to see. This is how you turn what you have learned into something you can show. Subscribe and do not miss it. See you in the final episode.